Okay, now let's see what we have in the solution to physics. We have explained the equilibrium of bodies in liquids. Now the question here is an object weighs 10.0 Newton in air and 7.0 Newton in water. What is the weight when immersed in a liquid of relative density 1.5? So let's quickly look at the solution of what we have here. If you look at the solution, I'm going to explain it step by step, and I will not rush this explanation so that you can understand it. Now, the first thing you are given here, let's look at what we are given. We are given the relative density as 1.5, and relative density 1.5 does not have units because it's a ratio of the same quantity. Then we have the weight of an object in air. Weight of objects in air, as we can see in the question, weight of objects in air, and that is 10.0 Newton. Also, we have weight of objects in water. Weight of objects, weight of objects in water, and that is 7.0 Newton. Okay, now from what we can see here, we know that the problem that we are asked, or what we are asked to solve, is the weight of the object in fluid. The weight of the object in fluid is what we are asked to look for. Weight of object in fluid, that's WL, is what we are looking for. So from here we know that upthrust of objects by water, the object is immersed in water. So what is the upthrust on the object by the water? On the object now, not of, on the object by the water. So this, in this case, when you insert or when you immerse an object in water, let me have it clearly. When you immerse an object in water, when an object is in water, we have two forces. This is gravity. This is the force due to gravity, and this is the upthrust, opposite that of gravity. And that is what we are going to see in solving this question, as you can see. So this is going to be the weight in air, the weight in air minus the weight in water, weight in air minus the weight in water. So the weight in air is 10.0 Newton minus the weight in water, which is 7.0 Newton, and this will give us 3.0 Newton. Now we've gotten that the appropriate formula that we are going to use is relative density, since we are given the relative density. So, and the relative density is the upthrust of objects in liquid over the upthrust of objects in water. We have actually explained that as well. The relative density is equals to the upthrust of objects in air, now in the liquid, because the object is in the liquid, now divided by the upthrust of objects in water, So when you do our substitution here, we have 1.5 equals to the upthrust of objects in liquid, that's UL, divided by 3. So we are actually looking for the object of in liquid, up thrust of object in liquid. So UL is going to be 1.5 multiplied by 3, and that will give us 4.5 Newton, as we can see here. Okay, generally, we are going to see that generally up thrust is equals to weight in air minus weight in fluid, that's liquid, and that is going to be weight of objects in liquid equals to weight in air minus up thrust in liquid. And from there we could see that that's going to be weight in liquid is equals to weight in air minus up thrust in liquid, and that's going to be 10.0 minus 4.5. That will give us 5.5 Newton, 5.5 Newton, and that is how we solve this question, as you can see.